Well, hello, everybody. Welcome. I've got a pretty cool IB style question here that we're going to tackle. So I'm glad you're going to hang out with me and do a little math together. So let's dive into the situation right here. Here's what we've got. We've got a spotlight. It's above the front of the stage. It's point A, and the front of the stage right here is point D. And the spotlight sheds a beam like this. And here are the dimensions: 10 meters, 8 meters, and 5.2 meters. So there's a couple of things we've got to figure out. We're being asked to find this angle right here, and we're also being asked to find how far back somebody that is 1.9 meters tall could stand and be fully lit. So this is exactly the types of questions that you're going to see in IB test. Let's see if we can get into it, shall we? Now, visualizing it can really help, because maybe that diagram doesn't really make a whole lot of sense to you, but this is more of what it would look like in real life. You're going to have a light up here. It shines a beam of light that's rather focused to bring everything that's in that beam to the focus and the attention of the viewer, like this. So that's our situation right here. So let's go ahead and start with the angle, shall we? So what's the angle of the light beam? Well, let's see what clues we have right here. We've got three sides of a triangle, and I guess the tricky part is actually seeing the shape that you have. So we've got this triangle right here. If I take it out of the context, this is what I've got. So now the next tricky part is figuring out what formula you can use. Well, since we have a triangle, we're going to use some trigonometry. And we can't use the Pythagorean theorem because it's not a right triangle, so we're going to either use the sine or the cosine rule. So if you're an IB student, hopefully you're familiar with this formula booklet. In the formula booklet, this is the way that the sine and cosine rules are presented to you, and we're going to use this one right here. Now, if you're not familiar with the cosine rule, I'll leave a link to a video where I give you a lesson on that in the description below. But for now, this is the formula that we're going to use. So there's our formula right there. Only thing we have to be careful of is that the unknown angle is opposite of the side 5.2. So 5.2 is going to be C. So when we plug everything in, it's going to look like this right here. And 100 squared, 100 plus 64 plus 5.2 squared divided by 2 times 10 times 8. Plug that all into the calculator, and you get 31.1. So we know our angle is 31.1 degrees. So hopefully that wasn't too bad. Now this next part, well, it's a little bit tricky. Here's what we've got. We've got to figure out how far away from the front of the stage somebody that is 1.9 meters tall can stand and still be fully lit. So visualizing that is a really good idea. So we got somebody on stage, they're 1.9 meters tall. How far back must they stand? Well, if they're here, they're obviously okay. They're fully in the light. However, if they are back here, they're too far back, and you can't see all of them because this part over here will be, well, not lit up. So they need to be right there, and we've got to figure out what that position is. So the thing we've got to know is that distance from the front of the stage, D, to this point right here. Now, the way we can do that, well, I've got a couple different ideas. I've done this problem in a few different ways, and I thought I'd share with you this way right here. I'm going to go ahead and create this little triangle you see in orange, and the distance from the stage to this point right here is the distance we need. So if I take that out of context, we're going to explore this triangle right here. I'll go ahead and highlight the perimeter in this yellowish orange color and put it back on our picture. That's what we're looking for right there. So we know that the horizontal distance is 1.9 meters above D to B, which is the stage floor. And yeah, so we got to figure all that out right there. Now, how can we do that? Well, let's go ahead and devise a plan. I'm going to figure out this angle, ABD, right here in the big triangle from ADB. I'm going to figure out ABD, and the reason why is because those two triangles are similar, so that triangle right there is the same. I don't have enough information to figure out that angle Y from the little orange triangle, but I do have enough information about triangle ABD, so I'm going to figure that out. And then we're going to figure out the distance from A to D, and we're going to subtract 1.9 from it. Because when I subtract 1.9 from it, what I'll have left is I'll have one side and one angle of a right triangle, and that is more than enough information to figure out this side, MD. to n, which is the distance from the front of the stage that somebody can stand, the furthest distance they can stand and still be fully lit by the light from the spotlight. All right, so let's go ahead and dive into that, shall we? So let's start off with trying to figure out this angle ABD, shall we? So we have our original non-right triangle right here, and we can use, for this one, we can use the sine rule because I have a side and the opposite and another side and its opposite angle are known. So that's going to be the sine rule right there. Again, if you're not familiar with the sine rule, I will leave a link to a lesson on that in the description below. But for now, let's go ahead and use that rule, plug everything in. So here's what we've got. Sine of y divided by 8, sine of y divided by 8, those are the paired opposites and angles, right? Divided by the sine of 31.1 divided by 5.2. So using just a little bit of inverse operations, multiplying both sides by 8, and then taking the arc sine of both sides, doing a little bit of calculator work, we can see that our angle is 52.6 degrees. All right. So now, what we have is we have this angle is 52.6, and since that angle is the same as the angle in the right triangle, so we had this little triangle right here, we found that the angle is 52.6. It's the same exact angle as ABD, so now we're good to go. All right, now we're going to find the side A to D. So let's go ahead and look at our triangle right here, kind of in isolation, right? So we've got a right triangle, which means we can use sine, cosine, or tangent. How do you know which one? Well, I use SOHCAHTOA if I'm not sure, right? So what we have here, we have the angle, we have the hypotenuse, we need the side that's opposite of the angle, so that is sine. So we're going to do sine of 52.6 is equal to the side we don't know, AD, divided by 10. So just multiply both sides by 10, and you got a little bit of calculator work to find that A to D is 7.94. Now that we know that that's 7.94, we can subtract 1.9 from it and figure out that A to M is 6.04. So 6.04 and 52.6 degrees, those are the pieces of information. Now we just got to figure out this side right here. Once again, we have a right triangle, and we have to figure out, are we going to use sine, cosine, or tangent? Well, I know the opposite side. I need the adjacent side. Well, opposite and adjacent, well, that would be tangent. Right, so the tangent to the angle is the opposite divided by the adjacent. So just doing a little rearranging right here, multiplying both sides by mn and dividing by the tangent of 52.6, we get this. We can plug that into our calculator, and we can find that the distance from M to N, 4.62 meters. That's pretty cool, right? Now, I would like to share a real quick note on rounding. The way I did this problem is I rounded to 3 significant figures after every major calculation, and that changes your answer a little bit. If you do this problem by finding a different triangle and different angles, like if you found this angle up here instead, you would end up with a slightly different answer. I ended up with everything from 4.62 to 4.82, doing it all correctly. That's not that unusual for these types of questions that IB likes to give. And that's why showing your work is incredibly important. So if you're about to take your IB test, make sure you're writing down your formulas, writing down your unrounded and your rounded answers, and just showing everything clearly, because you're giving somebody that's grading your test evidence that you know what you're doing. So anyway, I hope you learned a lot from this problem. I hope you had a good time with it. I think it's a pretty neat problem. And until next time, well, I hope you have a great day.